Okay, thank you for that great introduction. Looking forward to getting back at you maybe when I see you in Israel later next year. My name is Nader Dabit. I'm a developer advocate for AWS Mobile. AWS, of course, is a big company, and we have like small divisions within the company. The part of the company I work in is the mobile division, but we're slowly coming more of the client division because we're not only focused on mobile now, we're focused on web, we're focused on progressive web, we're doing cross-platform with Xamarin and React Native and other platforms coming in the future. And again, I'm a developer advocate, so a part of my job is to go out there and talk to developers and see kind of the tools that they're using, the AWS tools, and give feedback, bring it back to the team, find out what they want, bring that feedback back to the team so they can implement new features. We can get a good idea of kind of where our direction needs to be headed. And today I'm going to be talking about building serverless web applications with React and AWS. And when you think of AWS, a lot of times you don't really think of front-end developers. You typically think of AWS as being like a back-end service provider. You think of AWS as maybe being more on the tooling in general for DevOps and back-end in general. But our team is actually focused on front-end. We have an entire team in our AWS mobile. The whole team really is focused on front-end developers. And I'm going to talk about how that works. And if you'd like to follow me and hear more about what I'm talking about later on, I'm on Twitter, Medium, and GitHub, all under the same handle, Dabit3. I do a lot of writing. I manage 2 publications. One is React Native training, and one is Open GraphQL. React Native training is focused on React Native. We have publishers from all around the world that write there. Open GraphQL is kind of the same thing. It's an open forum for people to write about GraphQL technologies, and we focus on everything in the entire ecosystem, not just AWS. Total between the 2 publications, we have around 1 million readers a month right now. If you're interested in writing and getting in front of a large audience, also ping me and we can add you as a writer if you feel like you want to get into blogging. But to the topic at hand, the general idea about this entire talk is going to be around developer velocity. I've noticed that in my career, the more that I've focused on the idea of developer productivity, my productivity, the velocity of what I'm doing, the efficiency of what I'm doing, the more opportunities that I've had, the better my career has gotten. And in general, all of the technologies that I've focused on in my entire life have been focused around this idea of developer velocity. So that's kind of the core idea of this entire talk. A lot of times when you talk about this type of stuff, you hear about the 10x developer. Of course, you may have your thoughts about what this means. I've definitely met people that are 10 times or even 100 times more productive than me. A lot of times, though, they're only more productive than me in their specialized field. So if you're focused on a single thing, of course, you're going to be more productive. I don't really like the discussion of a 10x developer. It kind of abstracts away the core discussions that I think need to be had. What I do like to talk about, though, is this idea of the NX developer. And then the NX developer, I think, is taking your existing skill set and looking for technologies within that skill set that allow you to increase your productivity, increase your efficiency, and increase your velocity without having to actually learn something new. So basically taking what you know, finding things that you can apply these existing knowledge to become more efficient and more productive. This basically means doing the least amount of work possible to get the most output. And what are some ideas or what are some technologies that kind of fall into this category? At a very broad level, JavaScript falls into this category. That's because with JavaScript, you can learn a single language and you can build mobile applications, you can build web applications, server-side applications, now even machine learning, all kinds of stuff. Whereas in the past with other languages, and even now with other languages, most languages don't really allow you to do this. You might learn a language, but you're limited to what you can do with it. So specializing in something like JavaScript at a high level kind of falls into this category, I think. Also React and React Native, and anything that allows you to, again, specialize in maybe a little more of a specialized ecosystem. With React and React Native, you can learn one thing, and you can deploy now to Tizen, Apple Watch, iOS, Android, web, desktop, all types of places. GraphQL is another thing that kind of falls into this category. GraphQL, one of the main things that kind of allows this efficiency is the self-documenting API that GraphQL API gives you. You kind of can look at the schema. You can also do introspection and see exactly the different operations that are available to you. In addition, you have real-time out of the box. So if you're a server-side developer and you're building a real-time application, you don't have to build your WebSockets. GraphQL has as part of the specification is subscriptions, and then type safety. Type safety allows you to have less error-prone applications on the client. So when I joined AWS, I joined because the team that I was interviewing with is also focused on this idea of developer velocity. And a couple of the tools that we're going to be talking about today fall into this category at an extreme level, I think. Those two are going to be AWS Amplify and AWS AppSync. AWS Amplify is a combination of things. It's a client library that allows you to connect to cloud resources. It's a CLI that allows you to create cloud resources. So you basically create the resource from your CLI, you then connect to it from the client library. There's also now a console that allows you to deploy and host your applications after they've been built. And then we have also a CLI toolchain that's kind of part of the CLI that allows you to do things like generate GraphQL code generation. So if you deploy an API, you don't want to actually write all the mutations, queries, and subscriptions. The CLI will actually build all that code for you and store it locally into your application. So AWS Amplify is what I'm going to be talking about mainly, and then we're going to be talking about a little bit about AppSync. And the core idea behind AWS Amplify is to allow developers to build apps quickly. As a front-end developer, what we're trying to do is kind of bring full-stack development to front-end developers without having to have them learn all of the intricacies about building full-fledged back-end solutions, worrying about things like security, worrying about things like scalability, and all the things that a typical back-end engineer would need to understand. So really, we're trying to allow you to bring your existing skill set and build full-stack applications as a front-end developer. And when you talk about serverless, you'll hear a bunch of different people talk about what serverless means. And then you'll have someone make a little joke about serverless here and there. They might say something like, serverless, why is it called serverless? It has servers. Next time someone does say that, just give him my phone number because I want to give him a call and talk to him or her and have a nice discussion, because that's kind of the, one of the things you hear the most. That was funny at one point, but I guess it's not too funny now. I saw this thread yesterday and I added it to my slide deck. Butterfly, well, why is it called a butterfly? It doesn't have butter. Sponge cake, you can't clean with this. Cloud computing, it's not water vapor. Of course, there's all types of definitions about serverless. But for me, the main pieces that go into serverless are no servers to manage, continuous scaling and balancing. You only pay for the compute time that's used, not the compute time that's reserved. And also, at the core is less code to manage. And that's kind of going to be the main piece I'm going to be focusing on from here. So going from serverless to service full, these two things are starting to kind of fall into similar categories. I just saw a talk earlier talking about someone that works for a company that allows people to connect to a managed service to do all sorts of things like subscribe to real-time data and use it in your application without having to kind of manage that data for you. And service full, like managed services, kind of are going to be falling into this category of serverless. When you think of serverless, this is an interesting tweet that I saw. Serverless thinking: use a service whenever possible because services are almost always cheaper than people. Also, building with services is also going to be much faster than people, because you're not actually having to build this service from scratch. You're kind of hooking into an existing scalable implementation. So what exactly is a serverless application? Typically, what people think about when they think of serverless is Lambda functions, right? You think of I'm going to, instead of building and maintaining my own server, I'm going to hook into this Lambda function, and that's kind of what serverless is. And that's not really true, I think. I think the best serverless application is just like Joe Emerson tweeted out: thick client code handling all of the interaction logic, heavy use of managed services. Managed services are going to be things like Auth0 for authentication, AppSync or Firebase for your data layer. Algolia for search, Cloudinary. There's dozens, hundreds of, or maybe even thousands of these managed services out there. And they can actually do a lot of the heavy lifting for you. And then what cannot be done through these managed services, only then do you write your Lambda functions or your serverless functions to get the rest of the work done. But the core idea is trying to get as much done through these managed services as possible. And another interesting tweet that I saw from Joe is this: the key benefit of serverless is not no servers to manage, it's almost no backend code. So when you think of serverless, again, you typically think of these Lambda functions, but really the core serverless applications that are kind of the most productive are the ones that handle most of the logic for you and manage services. So you end up with just less code to maintain in general. So from now on, when I kind of mention serverless, I'm really talking about serverless in the sense of this serviceful serverless. So managed services that are serverless. You don't have to manage these services. They're kind of managed for you. They scale. They do everything you need. So what are the properties of a serverless service? A serverless, serviceful serverless service. This is kind of starting to get a little tongue twisting. Like, what are the properties of something like this? One of them is no server operations. We mentioned that earlier. It scales seamlessly. So after you launch and you get your 10 million users, everything still works. You're now worried about paying for the service, but you're not really too worried about it breaking. At least you have a different set of worries at this point. It's codeless in general. Yes, most of the services we're going to be looking at are actually indeed codeless. There's no need to manage uptime, and the bottom line is they assume responsibility for a defined set of services. So you know exactly what they're going to do. They have their own API that they've implemented, and you have to go by what API that they've given you, and then you kind of interact with it from there. So what are some benefits of this philosophy? First of all, you're trading your capital expense for variable expense. When you need something built, instead of paying a developer $40,000 to implement this for you, you're going to hook into something that's already there. Only when you start scaling up do you start paying for this. So you can test things out, you can try things out without having to actually invest a lot of money. So back in the day when electricity was first invented, when you have a factory, for example, you could not just hook into an existing power plant and just pay for what you needed. People were actually building their own power plants. And when you think of electricity today, you don't have to go to school to learn how to create electricity, pipe it into your house, and manage it. Now you just flick on a switch, the light company sends a bill in the mail at the end of the month, and that's how you consume electricity. What we're moving to in the cloud computing space is this idea, but more implemented in the computing space. So whenever you need a service, you just hook into it, you don't pay for it until you use it, and then you're only charged for what you use. You don't actually have to worry about the actual implementation. And that's kind of going to be along the lines of what we're going to be demoing in just a moment. And then less code. Less code is, with code being a liability, the less code, the better. So less code to maintain, less code to just have to deal with in general. Elasticity, of course, this again goes back to scalability and maintainability. So if you bring a new developer into your organization, you lose a developer, the less code that they have to deal with, the better. The faster that they can be onboarded, the quicker they can begin creating features and fixing bugs. I saw this quote and I edited it slightly. Go for an application that any idiot can maintain, because sooner or later, any idiot is going to be maintaining it. And most of that time, that idiot is me. Because when I go back to an application 6 months later, a lot of times I look at my code and I'm like, who is this idiot? I'll get blamed, that's me, okay. But really, bottom line, less code, the better. That's kind of the core idea behind all of this stuff. And then experimentation. If you have an idea that takes 6 months to implement, but you don't know if it's going to work, how likely you're going to be to implement this idea? If the same idea takes 2 weeks or 2 days, you're a lot more likely to experiment, which then leads to more success because you're able to fail faster, you're able to try new things out and do so more quickly. So this comes down to, like, how do you actually implement this architecture? What are some ways to get to do this? There are multiple cloud providers, there's multiple service providers that do offer these types of services. What we're going to be covering is AWS's offering called AWS Amplify. And AWS Amplify has three main parts. First, it's a CLI. So if you're a front-end developer used to working from the command line, this is going to feel very nice and very familiar for you. If you've ever built a Rails application, actually, it's very similar to Rails. You just type in a command, you have something that's scaffolded for you, some decisions are made, and then you're able to start working on that thing right away. After you've created your service with the CLI, you then connect to it using the JavaScript client library or native iOS or native Android, whatever you're working with. So you create the service from the CLI, connect to it from the client, and then you can host and deploy it as well. We have a console. You can actually do continuous deployment using Git. I'll talk about some of those features in just a moment. But we'll go over each of these in one at a time first. So the client library allows you to connect and interact to these cloud services. We have pre-configured components for popular front-end libraries that we'll go over in just a moment. AWS Amplify is open source, so we do that for a couple of reasons. We have a large dedicated team that is doing nothing but building this. It's open source because it allows us to have a forum for people to submit issues, submit bugs, ask questions. All of this stuff is searchable and out in the open. You're also welcome to submit pull requests, of course, to documentation, but and for features or whatever. But the main reason that we have it open source is to kind of have an open forum, an open dialogue, have it discoverable. And then also it's pluggable, so it's not only works with AWS, it works with pretty much any cloud provider you'd like to work with. Most of them are aimed at AWS services, but they're, again, available to work with any cloud provider. Some of the libraries that we support right now, first class, we support Angular, we support Vue, we support React, and we support React Native. So you can use Amplify with any JavaScript application. It doesn't have to be one of these frameworks. We just offer additional features for these frameworks. And we're going to look at one in just a moment, but we abstract away a lot of code, a lot of functionality, and just a few helper functions with some of these frameworks. But we also offer a full suite of classes that you can just implement all of the different features directly using the classes as well. So the CLI allows you to create cloud services. It allows you to update and delete those cloud services. And then it also allows you to do the GraphQL code generation I mentioned earlier. And then finally, the console. The console allows continuous deployment and hosting services for mobile web applications. Right now, we're going to be adding additional platforms in the future. We have Git integration with GitHub, GitLab, and Bitbucket. So you connect your repo to our console. We automatically build and deploy your application, the front end and the back end. When you make changes to master or whatever branch you have connected, we then rebuild and redeploy your application. We also have password-protected deployments. So a lot of times you have a dev branch, you want to be able to have people test it, and you don't want it open to the public, but you do need a live URL. We provide that for you out of the box as well. So what kind of services can you create with Amplify? We have over a dozen different ones, but these are kind of the main ones that people are working with. Authentication, something very similar to Auth0 we have called Amazon Cognito. Analytics. Analytics works hand in hand with our push notifications, our SMS and email notifications, so you can trigger these notifications from events that are captured in your analytics. We have GraphQL APIs using AWS AppSync. AWS AppSync is a managed GraphQL service that allows you to spin up a GraphQL API in just a couple of seconds. We handle everything for you, so you don't really have to actually build and worry about the security and all of that. It's kind of handled for you. Lambda functions. Two exciting ones are AR, VR, and chatbots. So you can build scenes and deploy them using the Amplify client. And you can actually build and deploy chatbots from the command line, which is pretty cool. REST APIs, storage, S3, push notifications, I mentioned, internationalization. That's kind of a client-side library, the internationalization part. So how do we kind of get going with this? I'm going to be walking through a demo in just a moment where we're going to be taking an empty React application from a Create React app. We're going to be installing or creating a new Amplify project. We're going to add user authentication. We're going to create a GraphQL API. We're going to connect to the GraphQL API to create mutations, and we're going to query that data. And then if we have enough time, we'll then implement fine-grained access control and authorization rules on the actual API, so you can only fetch the data that you've created. So there are a few steps to get started with the CLI. First of all, you install it globally. So npm install -g at AWS Amplify /CLI. You configure the CLI one time. This is just the one-time step you do after you first install it, because the CLI needs to know who you are, because it's going to be creating these services on your behalf. So we walk you through the steps to go into the console, create a user, and then put the data, the keys that you need locally to identify the user. And then once you've configured Amplify and you've installed it, you can start initializing new projects. To do that, you'll have the Amplify command available. You run amplify init. This initializes a new project for you. To create services after you've initialized the project, you can run amplify add. So amplify add auth, amplify add hosting, amplify add API, so on and so forth. And then finally, after you've initialized all of these services locally, if you want to go ahead and push those and update them in your account or even create them in your account, you run amplify push. So that's kind of the 5 steps that we're going to be walking through in just a moment in our React app. And we want to build an example application that kind of covers a lot of the main features a typical application would need. So a typical application needs user management, it needs a data layer, it needs search, and typically analytics and reporting. So that's kind of the application. We're going to kind of build all 4 of those main features using the CLI. So the features that we're going to be creating are going to be using these services. For the data layer, we're going to be using AWS AppSync with a NoSQL database. For identity management, we're going to be using Amazon Cognito. For search, we're also going to be using AWS AppSync because we're going to be searching from our data layer there. And for analytics, we're going to be using Pinpoint. So I'm going to go ahead and switch over to my command line. And we're going to be kind of doing this in 3 steps. The first step is we're going to create the Amplify project in an empty React application. Then we're going to, after we've initialized the Amplify app, we're going to then add the services. And then after we add the services, we're going to then push the services up into our account and test out our application. So in our, let's see here. So in our application, we have a basic React app built out. We have a source folder, all of our typical stuff. So if we look into source, we have all of the things we would have in a React app. So to get started, we'll go ahead and initialize a new app. So to do that, we'll run amplify init. Amplify init will now walk us through a few different steps. The first step is for us to enter a project name. For this project name, we're going to call this conference app. And the conference app is going to allow us to create talks and create, I guess, users that are speakers that are going to be talking in the conference. For the environment name, we're going to give this an environment name of dev, because we can create multiple environments. So typically you'll have like one environment that you're developing on. You want to create a new feature, you can actually create a copy of your environment for that feature, deploy it, test it out, and then merge that back into your original environment. For the default text editor, I'm going to choose Visual Studio Code. Now, since we're inside of a React application, the rest of the questions are going to be kind of auto-detected for us. So it's going to ask us the type of app, JavaScript, the type of framework we're using, it's going to be React, the source path, which is source, distribution, which is build command, which is also build, and start, which is npm start. So we can kind of just take all of the default settings from there. Next, it's going to ask us for our AWS profile. The AWS profile, let me try to maybe bump this text size up a little bit. The AWS profile is going to be the user that I mentioned earlier that we need to kind of associate with this initialized application. So I'm going to use an existing profile that's on my machine. I'm going to use EU central user. So this is going to initialize the Amplify project. Once this project is done initializing, we'll then going to go ahead and jump to step 2. Step 2 is going to be after the Amplify project is initialized, we can now run Amplify status and see information about our application. We're in the dev environment. We don't have any categories enabled, but if we do look in our directory, we have a new folder called Amplify. This is a folder that's created and configured for us by the CLI. It's going to take up any resources that we've created in the cloud and have references for them locally. And if we look in SRC, we'll also see a new file called AWS exports.js. This file was also generated for us by the CLI. It's going to be what we use to configure our Amplify application. So after we've initialized the app, we can now start adding services. So the first service I want to add is authentication. To do that, we run amplify add auth. We're given two options. We can either take a default configuration for our authentication strategy. This will have multi-factor authentication for sign up, and for signing in, you only are required to have a username and password. You can also set up your own configuration and set up everything from password roles to the email that the user gets for MFA, the type of MFA, so you might want phone number or time-based one-time password. It gives you about 15 or 20 steps to kind of walk through and choose all of your own configuration. Since for this demo we want to go with something simple, I'm going to actually take the default, which is just the basic MFA for sign up, and also just username and password for sign in. So now that we've added our authentication service, we now need to add the GraphQL API. So to do that, I'm going to run amplify add API. There are two different types of APIs that we can create. One of those is GraphQL. GraphQL is using AWS AppSync, of course. And then we have REST. REST will give you two options of APIs that you can create. One of those is a serverless Lambda function with an Express application running in it. So it'll give you a completely scaffolded out example Express app with different routes that you can use. The other REST endpoint that you can be given is a DynamoDB database table or DynamoDB database along with the serverless application again that will give you all of the CRUD operations you would need for create, updating, and deleting. We're going to choose GraphQL. For the name of the app, I'll call this comp app. For the authorization type, we can choose a few different authorization types. Two of them are given to us here in the command line. The other two are configurable through the console. API key is a really open form of authorization. Anyone with the API key can pass that in the headers and make calls to your API. A more secure form is Amazon Cognito user pools. We already have authentication set up using Amazon Cognito, so we can actually choose this and it'll automatically detect that and configure it for us. We also offer OpenID Connect, which allows you to kind of bring your own authentication provider. So if you're using Auth0 or you have rolled your own authentication service, you can use that. So I'm going to choose Amazon Cognito user pool. Now it detects we already have a user pool configured, so it says use a Cognito user pool configured as part of the project. So it kind of detected that. Next, it's asking us if we have an existing GraphQL schema. So if you have an existing GraphQL schema in your project, you can choose yes and kind of give it the file path for that. But we don't. We're starting from a brand new React app. We want to have a guided schema creation. It's going to give us an example type. It's kind of like a boilerplate for a GraphQL schema, and we can go from there and edit it ourselves. So I'm going to go ahead and choose yes. Do we want a guided schema creation? So what best describes our project? We're given three boilerplates that we can start with. The most simple is the single object with fields. It's just a type of to-do with an ID, a name, and I think a description. We also are given an option of one-to-many relationships or fine-grained access control. I'm going to start off with the most basic single object with fields, and I want to edit the schema, yes. So this is going to go ahead and take us into our text editor of choice, and it's going to give us that example schema that we can go ahead and edit now and modify. I'm going to go ahead and populate the schema that we're going to be working with. We're doing a conference API. We want to have a type of talk, the name of the talk title, I guess, the speaker name, and the speaker bio. That's the only information we kind of need for our GraphQL schema. You might notice that we have a decorator here for @model or a directive. What Amplify uses also under the hood is something called the GraphQL transform library. GraphQL transform allows you to add directives like this @model to do additional things into your API. So there's 3 different directives: model, connect, and auth. Model will scaffold out a database table for you. It will also add additional schema for all of the different GraphQL operations that you need. So for a typical type, you might want to have a query for getting that talk. You might want to have a query for listing all of the talks. You might also want to have mutations for creating, updating, deleting. And then you probably want subscriptions to listen for on create, on update, and on delete. All of that stuff will be actually created for you. Also, the resolvers between the actual operations and the data source will be created for you. So you get the schema scaffolded for you, you get the resolvers and the data source by using this @model. @connect will allow you to create relations between types, and @auth will allow you to add authentication rules. But for now, we want to start off with something basic, so we'll just go with this @model. And we'll go ahead and click enter. So now if I run Amplify status, we'll now see that we have 2 different categories that are enabled. We have auth and we have API. To go ahead and create these in our account, I can run Amplify push. So it's asking us if we're sure we want to continue. I'm going to go ahead and choose yes, because we want to go ahead and operate these create operations. And next, it's recognizing that we have a GraphQL API that we're about to create. So it's saying, do we want to generate the code for you for your GraphQL API? So if we want to do that, we can choose yes. And this is going to go ahead and give us the option between creating this code in either JavaScript, TypeScript, or Flow. I'm going to go ahead and choose JavaScript. Now we can give the pattern for where these files are going to be living. So we have a source directory. It's going to go ahead and populate the source/GraphQL/ the name of the operation / the operation name /JS. So what that is going to basically do is create a new folder called GraphQL and add mutation subscriptions and all of the mutation subscriptions and queries. So I'm going to go ahead and just take that default because that kind of works for me. And do I want to generate all of the operations? Yes, why not? So this is going to go ahead and create all of these resources in our account, but also it's going to go ahead and create the code for us locally. So now I'm going to go ahead and open the project. And I'm going to go ahead and undo some of this because I was testing this out to make sure that everything was working before. And we're going to start writing this from scratch. So we have a React application, and we go ahead and start this up. And this is going to be like the base app that we're starting with. You may have seen this before. This is just a basic Create React app. So the first thing we want to do is we want to add authentication. So to do so, we need to do 2 things. First of all, we need to let the React app know that we have this Amplify project available. To do so, we're going to run an amplify.configure command at the root level, which is the index.js. Second of all, we want to then add something to our app.js to add this authentication. So let's go ahead and do that. In index.js, I'm going to go ahead and do amplify.configure. So we import Amplify, which is the Amplify library. We import that AWS exports file that I mentioned earlier that was created for us by the CLI right here. That has all this information. We don't really need to ever mess with that. So we import Amplify, we import our config, and we call amplify.configure, passing in the config. We're done with index.js, at least for now. Next, we want to add authentication. So one way to do that was we could import the auth class from Amplify, and then we could call methods like auth.signin, auth.signup, auth.whatever. We have all these over 30 different methods to handle that. But we're going to be using the React framework helper called with authenticator. That's going to allow us to kind of do this in just a line of code or 2. Let's see here. So we're going to go ahead and import with authenticator from AWS Amplify React. That's a framework-specific library from React. And then we're going to be, instead of exporting the default as the class, we're going to instead export the with authenticator. Okay, so now we've done that. We can jump back to our React app and see what it looks like now. So this is the app now. If I refresh, we're not able to get into the app until we sign in. So I'm going to go ahead and create an account first. The username, password, all that stuff. All right, so we've signed up. Now we should be getting an MFA code in our email. So let me check my email. Here's our verification code. I could just copy this, paste it here, and confirm. Now that we've signed up, we can sign in. So I'll go ahead and sign in. All right, we're signed in. So now that we're signed in, how do we sign out? Well, I can actually go ahead and add another argument here called include greetings. So with Authenticator takes a set of arguments that allow you to update the styling, allow you to update whatever it is that you'd like to update as far as the configuration for the with Authenticator. After updating that, I now have a sign out button and I also have a greeting with my name there. So when I refresh, you're going to see kind of a quick loading. That means it's kind of looking for the local storage to see if there is a current user. If there is, it lets you see the application. If not, it forwards you to the sign up form. So now that we've signed up, how do we actually fetch data from our API? So when we created the conference API, we have now this conf app-dev. That's the API we just created. The API that we're going to be using is basically a copy of that API configured for the project that I'm in called conf app API. And here, this is kind of the AppSync dashboard. It allows you to do a bunch of things there. But this is kind of just a quick look like that the API was created for us. But we can do everything we need from our command line and from our client-side environment. So the first thing we want to do is we want to configure our app to recognize AppSync. So AppSync has two different client libraries that you can work with. If you've ever worked with GraphQL, you may have worked with the Apollo library. We have an Apollo kind of fork, and it allows you to have the same API that Apollo has. So you can either use that, or you can actually use the Amplify GraphQL client directly. So we have two clients. One is Amplify, one is AppSync. The Amplify client allows you to do all of the basic operations like queries, subscriptions, mutations, and those sorts of things. But what it doesn't give you is offline or caching. So we're going to be using the AppSync SDK for that because Amplify does not allow that. So first, I'm going to go ahead and import the AppSync client, which is similar to the Apollo client. I'm going to import rehydrated, which is what allows us to read from the local cache. I'm going to import Apollo provider, and I'm going to import auth. Apollo provider allows us to inject a client into our application. Auth is what allows us to fetch information about the user. And I have about 1 minute left, so I might make the rest of this kind of quick. After we've imported those, we can now create a client, just very similar again to Apollo, where you create a client variable. We're calling AWS AppSync client, passing in the configuration from the AWS configuration that was created for us. We have this app with provider component now that we're wrapping our main app in. This provides the client injected into our application. And instead of returning the app, we're going to now render the app with provider. Next, in the app.js, we're going to go ahead and import the imports that we're going to need for interacting with our GraphQL API. One is GraphQL and one is the compose. These are two higher order components from React Apollo. We import the list talks and create talk operations that were created for us by the CLI. And then we have this GraphQL mutation helper from AWS AppSync. Next, we'll go ahead and create our initial state. This is going to keep up with the conference name, the speaker name, and the speaker bio. Next, we'll have an onChange handler to keep with the user as they type, to keep up and update our state. And then we'll have a createTalk method that we'll call createTalk, passing in the state, which again is just this name, speaker name, and bio. And then finally, we'll just drop in the UI that we'll need for all this to work. The UI is 3 inputs, 1 to keep up with the name, 1 to keep up with the speaker name, and 1 to keep up with the bio. We then map over the talks and just render them to our UI. And then to make all this work, we're going to go ahead and create our compose method that has, this is just straight up really Apollo. If you've ever worked with Apollo, the same API. The only difference is we have this GraphQL mutation helper that allows us to abstract away the optimistic response and the update handler. And then instead of the app, we're going to be passing in the app with data, and then we're going to create our styles, which are just basic styles. So I'm not going to walk through those. But now if we go back to our app, we should be able to refresh and see that we have our form. So I'll go ahead and create my first talk. Create talk. Now if I go to my API and I go to data sources, and I'll look at my data source, I look at my items, I see my talk is there here. If I refresh, everything still works. And to finish this off, I'm just going to go offline real quick because I want to show you how you can actually make this work offline. So I'm online now, but what I want to do is I want to go offline. So I'm going to go ahead and click offline. So I'm offline, right? I'll go ahead and offline talk, some bio, some person. And I click create talk. We see that it still works. Now if I go back online, you'll see the network request was initiated for us because the client that we're using actually handles offline for you.